Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Canal lining. Canal lining. You can look to the pictures. I believe that's clear for canal. Calculation of loss by dropping out of leakage canals. Table of losses by leakage from the earthing canal that it is very rigid. This is a type for soil and the losses by cubic meter second square meter per day. The equation used by Ministry of Irrigation Egypt to measure water loss in waterway. Q small equals C multiply L multiply P multiply R under square root. Q small leakage losses along the canal cubic meter by second. C equal A coefficient depends on the nature and temperature of soil. L canal length in kilometer. P wet bottom wetted parameter in meters. R hydraulic radius by meter. However, many researchers have taken different methods to calculate the leakage loss more accurate than the Echeverry experimental method, taking into account the permeability coefficient of the soil, the shape of waterway, and the thickness of the porous soil layer. Given the complexities of mathematical equation here, we suffice with some simplified equations and diagrams that help to calculate the leakage losses. The equation used by Irrigation Ministry in Egypt to measure water loss in waterway. The equation that presets the leakage per unit length from natural waterway, where the groundwater level is agreed depth from the water surface in the waterway. Q small equal K multiply P plus 2D. The form of water leakage from natural waterway in the case surface of the groundwater is at great depths. At great depths. K coefficient of response imperishable soil. It is in the form of water leakage of natural stream in the event that surface of the groundwater is at great depths. It is clear that the flow lines are running flow lines and become vertical at depths. We have equation T naught equal 3/2 multiply B plus 2D. At the depth of T naught is the distance between two maximum flow lines. 2 multiply X equal Q over K. In the case of the canal whose section is trapezoidal and the surface of the groundwater is at a large distance T, the leakage loss per unit length can be calculated from Vedra-Inikov equations. That's happened in 1970. Q equal K multiply B plus AD. A capital is a coefficient. It can be found from the following figure corresponding to a set of curves that depend on the lateral slope m. Therefore, the distance between the maximum flow lines is 2x equal b plus a multiply d. This is shape for more value for m, relation 2 over d أكبر من 2 naught over d. Relation between b and d with a with difference m. It is noted that the depth between the surface of the water in the canal and the surface of the groundwater has significant impact on the rate of leakage from the canal. Figure 4.6 shows the value of K over KD terms of the ratio of B to D, different values of T over D, and this diagram is based on thighs slope M equal 1.5. This shape for figure C is difference for M equal 1.5, vertical K over D, horizontal B capital over D. Different type of T over D. This in case T over D less than T naught over D. If there's a trapezoidal section, B over equal B capital over equal B plus 2MD. For easy calculations, the equations must be placed in the form of the dimensionless. Usually use dimensionless. T naught over D equal 1.5 multiply X plus 2M plus 2. Figure 5C shows the transition limit between the small depths and the large depths of the groundwater surface when calculating the leakage. It's cocktail, yeah. The summary of the solution in calculation the losses by dropping out of the education. Figure 5x gives the graphical solution to the function. T naught over D functions with the x and m. We use a simple depth method which uses the figure for x in the case of T over D less than T naught over D. But we use the large depth method which used in figure 3 and which the equation is used Q equal QB and plus AD in case of T over D more than T naught over D. The next lecture will be an example for it.